With TSQL, you have to explicitly write each column in the group by clause that is not in the aggregate function. In Snowflake, you can do that as well, or you can use group by all. With TSQL, if you accidentally leave a trailing comma at the end of your columns, it will not run. With Snowflake, it'll run just fine. With TSQL, when you create a temp table, you must explicitly drop it at the bottom. Otherwise, it won't let you rerun it. With Snowflake SQL, they use the create or replace temporary table, and that does not require you to have a drop statement at the bottom. You have the option to use create temporary table or create temp table. With TSQL, when you divide by 0, you of course get an error, and that's never fun. Your main option is to use a case statement to try to handle what happens when you're dividing by 0. In Snowflake, when you try to divide by 0, you also get an error. To avoid this, you can use the div0 function to never have to worry about this again. With TSQL, when you divide by null, no surprise, your result will be null. It's like a black hole. In Snowflake SQL, when you divide by null, your result will be null. But you do have the option to use the div0 null function to instead make the result 0. With TSQL, when you make a calculated field, you can't immediately go to the next line and start making another calculated field with it. To do that, you have to put it inside of another query. With Snowflake SQL, when you make a calculated field, you can immediately go to the next line and make another calculated field from it. In TSQL, to mimic a COUNTIF function, you have to use case statements and sum. In Snowflake, they have a COUNTIF function. In both TSQL and Snowflake SQL, select star gives you all the columns. But if you're in the scenario where you don't want one or two columns, in Snowflake you can use the exclude function. In Snowflake SQL, you can make a column have the array data type using array construct. From there, you can choose to make queries where elements from the array are columns. In this example, element 0 and element 2 are two different columns. The other option is to have each element of the array as rows, and for that you would use lateral flatten. With both TSQL and Snowflake SQL, you have the option to pivot the results of a query. With TSQL, you have to write a bit more in the select statement. With Snowflake SQL, you're able to do select star. With Snowflake SQL, instead of explicitly writing count and group by, you can run select star, hit run, click on the column you're interested in counting, and the results will show up in the right pane. With TSQL, when you write not equal to in a query, it will not include null values. To include null values, you write not equal to or is null. With Snowflake SQL, you have the option to use is distinct from. With Snowflake SQL, when you create or replace tables, you have the option to undrop them. In this example, I'll use create or replace on a table to mimic what it looked like at 2 p.m., 3 p.m., and 4 p.m. At this point, the table has the 4 p.m. records. To undrop, you have to rename the table and give it a new name, and then undrop the table with the name it originally had. Now the table will have the 3 p.m. records, and a second table with a new name will have the 4 p.m. records. To get back to the 2 p.m. records, we have to rename the table to a new name yet again, and undrop the table with its original name. Keep in mind there are now 3 tables to hold each of the snapshots. In Snowflake, you can use time travel when you're using delete or truncate on a table. In this example, we'll save the query ID each time the table is truncated. That way we can go back to what the table looked like before. So now the table currently has the 4 p.m. records. Using the query ID, we can go back to the 3 p.m. records, and then the other query ID takes us back to the 2 p.m. records.